let f(x) be a function. And I have mentioned in the previous video why we define f prime a to be limit x tends to a f(x minus f a over x minus a, provided the limit exists. If f prime a exists, we say the function f is differentiable at x equal to a. And we say that f is differentiable at any point. F is differentiable at any point a in the domain of f. If f is differentiable at any point a in the domain of f, we say that f is differentiable. Here we have the formula for all the common function. If f(x) is, you have f(x) power n, then the derivative is n f prime x f x power n minus 1 and so on. I suppose you have done this in poly. Okay, and you can change this to the normal formula. You can change this to differential x power n. Differential x power n is actually n x n minus 1. You just replace f, means all the f(x), you just change it to x. And then all the f prime x, you just change it to 1. So it's like you omit it. So f(x) you change it to x, become x power n. And f prime is, you just take it as 1, so it's like you delete it. And this one you change to x, so it's n x power n minus 1. So that will be the usual formula given in textbook. Okay, then it means if you have cosine x, instead of cosine fx, cosine x, if you differentiate, it should give you negative sine x. So it means just replace fx by x, f prime x by 1. Then you can change off. So the last one, differentiating arctangent x or tangent inverse x, is to give you 1 over 1 plus x squared. Okay. Later I'll talk more about all this formula as we need it. First you have this product rule. ddx uv is v du dx plus u dv dx. So this is product rule. And we shall look at the example in the latest slide. Latest slide you have an example. So it's slide 20. You have differentiating x squared tangent inverse x. So let me use it as an example. So what you want is to differentiate x squared tangent inverse x. So what you do is basically you keep one function and you differentiate the other function. So which means you can take this as u. It means you take u as one of them, v as the other one. So you take this as u, this as v. So you take u as x squared v as tangent inverse x. So that means you keep v. So you keep tangent inverse x. Then you differentiate x squared. So it's ddx x squared. And then next you keep x squared and you differentiate tangent inverse x. Differentiate x squared will give you a 2x. Differentiate tangent inverse x, right? We have a formula, right? Differentiate tangent inverse x is 1 over 1 plus x squared, which I just mentioned. So it's 1 over 1 plus x squared. So the next answer is 2x tangent inverse x plus x squared over 1 plus x squared. Next you have this quotient rule to differentiate a fraction. Differentiate u over v is v du dx minus u dv dx over x squared. I'll show this example, which is also needed later in slide 20. It's ln x over x. So it means you take u as ln x, v as x, and then you can apply the quotient rule. So it's over v squared, right? And it's v du dx. V is x. Du dx means you differentiate ln x minus u is ln x, then d dx of v is just x, and over v squared, so it's over x squared. And this will give you x bracket 1 over x minus ln x bracket 1. Remember, if you differentiate ln x, this should give you 1 over x. Then if you differentiate x, you get 1. So that's how you get the number 1 here. That's how you get 1 over x here. You differentiate ln x is 1 over x. Then you divide by x squared, which you can simplify to x and 1 over x cancel to give you 1. 1 times ln x is ln x, and over x squared. Let's refer back to the formula. Ln x is here. So to differentiate ln x, just now in the lecture slide I mentioned, in the lecture video I mentioned, you replace fx by x, right? And f prime x, you replace it by 1. Then you get ln x, differentiate ln x is 1 over x. Fx replaced by x, f prime x replaced by 1. So differentiate ln x is 1 over x. So that's how you get differentiate ln x is 1 over x. So this is the formula. So with that, differentiate ln x over x is this answer. So we keep this in mind. We'll need this later in slide 20. Next, we have this chain rule. Chain rule tells you to find dy dx, you find dy du, then multiply by du dx. One example will be y equal to sine x cubed. So we can take u, we can let u to be, that means we let u to be x cubed. Okay, with that, after you let u to be x cubed, then y is just sine u. And from here you can find dy du. Dy du will be just differentiating, so you can find dy du. This should be u. Finding dy du. Okay. Because after you let x cubed be u, y is sine u. So you can talk about differentiating y with respect to u. So it's just d du sine u. So it's just cosine u. Remember, differentiating sine x will give you cosine x. Just replace fx by x, f prime x by 1, so it's cosine x. Then differentiate, you can also find du dx. Du dx means you differentiate x cubed. So it's d dx x cubed, which will give you 3x squared. So with that, according to the chain rule, right, dy dx is dy du times du dx. So it's actually sine u bracket 3x squared. And u can be replaced by x cubed. So it's sine x cubed and 3x squared. So usually you write the x squared term in front. So it's 3x squared sine x cubed. Another way to look at the chain rule, right? You can take it as it's like this. You can take it as dx y equal to du y then times du dx. Okay, and then you can take it as ddx. You replace y by a box, so you take it as ddx box equal to ddu box, then du dx. Later, when you do parametric differentiation, then you'll find this is useful. Next, I would like to show you how to do differentiation using boxes. Using, for example, y equals sine x cubed. You want to differentiate y equals sine x cubed. Okay, we know that if you differentiate sine x is cosine x, you can take this as ddx differentiate sine box is cosine box, then ddx box. Okay, that means in the formula you know that differentiate sine x is cosine x, and when you want to differentiate sine x cubed, because is no more x, is x cubed, so to do that you just replace all the x by box. Means in the formula you replace x by box, so differentiate sine box is cosine box, then you add ddx box. Okay, that means you replace x by box in the formula for differentiation. Then you just add the term ddx box. Then you find it works very well, and you can do it as many times as you like for complicated expression, which you may need various differentiation formula for different functions. So you add ddx box. So you add ddx box beside. So with that, right, to differentiate x cubed sine x cubed, to differentiate sine x cubed will go inside the box. So that means x cubed will go inside the box. So you fill in x cubed to all the boxes. So that means you can say dx of sine x cubed is same as x cubed is inside the box. So that means the answer will be cosine x cubed, then ddx x cubed. And this you know the answer. Differentiate x cubed is differentiate x power n. Differentiate x power n is nx n minus 1. So this one is differentiate 3x, x cubed is 3x squared. So the answer is 3x squared. So the answer is 3x squared, right? So the answer is 3x squared cosine x cubed. And let me go back to amend my answer here. This one is cosine u. Let me amend my answer here. So the differentiate sine u is cosine u. So dy du is cosine u. Dy du is cosine u. Cosine u. So this one should be cosine. So this one should be cosine u. So with that, you see your mistake, right? If you do it the other way, you do it together. So you see that if you do it this way, you fill in cos. You fill in x cubed, x cubed, x cubed. So you start with cosine x cubed ddx x cubed. So you add this step. So the chances you make careless mistake is lower. Then differentiate x cubed equal 3x squared. So straight away you get 3x squared cosine x cubed. If you do chain rule, right, you find the dy du here, and then you copy the answer into the chain rule formula. Then when you copy, then you might make careless mistake. So this one should be cosine u cosine x cubed. It's cosine u. U is x cubed. So it's 3x squared cosine x cubed. So we have the same answer. So basically, if you replace x by box, you add ddx box, you are actually using chain rule. But you don't write, it's like you don't have to go through the trouble to let u be x cubed, then and then you find dy du, you find dy du, then you find du dx, then you multiply the two answers. So all this formula, right, you can change it to box, and then you can use it easily. We will look at more example later using boxes. So either way, you still get 3x squared cosine x cubed. So this way, you just need to replace x by box, and add ddx box. You can try it out for all these functions, and then you can try some of the, when you do a tutorial, right, you can also try this method. Of course, you can do the way you learn it in poly, and you don't follow exactly what I taught you, it's okay.